Greetings wind lovers across the world. This video contains some of the footage from Storm Gerrit. There will be 3 separate videos, maybe more. The turbine ran very well all night, although at times I was very nervous indeed. Not because of any inherent faults or weaknesses, but because the wind was savage and relentless. The estimated wind speed was in between 20 and 60 miles per hour. Before the wind blew in, I decided to remove the Chinese budget controller and just used an old-fashioned big DC rectifier. This meant that there was no actual brake to stop the turbine going over 30 volts. 30 volts is an important number because my DC to AC inverter shuts off above 30 volts, and therefore cannot be used whilst in this state. I plugged 2 500-watt lights into the inverter, and this was acting as a 1 kilowatt power drain. Now the inverter is connected. What follows is this. The turbine starts producing 40 amps. This causes the battery voltage to increase sharply upwards to 27 volts or thereabouts. At this time the inverter switches on and immediately drains all the power out of the batteries, which has a knock-on effect of making the turbine have to work much harder. The battery voltage drops down to 21 volts and the inverter switches off. This process simply repeats itself for hours and hours on end. I have found this to be a great way of dealing with the storms and wind speeds of above 40 miles per hour. Please note that in the video, when you see the watt meter lit up around the plastic on the outside, that means the 1000 watts of lights are on and causing the power drain. The inverter is rated for 3 kilowatt, but I have only ever used it up to a maximum of 1 kilowatt, and it has proved to be very reliable, running for over 24 hours non-stop. The turbine produces over 100 amps in bursts, and the system is only limited by the wind speed and my 2 very old batteries. Regarding the build quality, the double bearing assembly at the top of the tower means that the turbine can easily handle being chucked about for hours on end. The struts at the back also mean the weight of the tail is supported. Without these 2 things the turbine would fall to pieces. My estimates are that the motor was probably going over 600 RPM at its peak. With regards to the gearing setup, this is running a 28-tooth sprocket on the drive shaft and an 18-tooth on the 3 kilowatts electric bike hub motor. I am glad that we sorted out all the problems with the turbine, and having to fix the motor was a bit of a mission, but all worthwhile in the end. Make sure you watch the whole video as the power really starts piling in at the end of this video. Please leave any comments and I will address them in part 2. Let me know if you like the voiceover or not. Thanks for watching.